Hey, how's it going? Today we're going to look at surface area, and in this whole chapter, chapter 11 is on three-dimensional objects. So we're going to do surface area, not just flat area, but surface area, and then we'll also look at volume in this chapter. Today we're going to look at all things surface area with prisms and cylinders and pyramids and cones. It boils down to just knowing some formulas and being familiar with those. So let's look at an example here. These are prisms. A prism is going to have two bases, one on the bottom, one on the top. Those are going to be the same shape, and then all of the faces, all these sides here, are going to be rectangles. That's how you know you've got a prism. In this case, we'd have a pentagonal prism. It's named based on its bases. And then these are called lateral sides or lateral faces. Lateral means the side. Okay, this next one's a triangular prism because the bases are triangles. A right prism just stands straight up with a right angle perpendicular to the ground. It can lay on its side and still be considered a right prism. An oblique prism is something that tilts off to the side. And we'll deal with some oblique prisms, but mostly be dealing with right prisms. All right, so first I thought maybe we should practice drawing some of these so that when you're drawing pictures and filling in stuff, you can draw it. Because when you draw a square prism, you typically kind of look at it from an angle, and so you don't really draw a square for the base. It typically will look like a parallelogram. So try to draw, and really it might be more of a rhombus than anything since this is supposed to be a square prism. But you do one like that, and then you do another matching one right above it. And try to make it match and line up the same way. Because what you're going to do then is join all the corners. If it's something that's in the back and you can't really see it, we typically will dash that. Okay, there's my square prism. Okay, a hexagonal prism. Now, in the last chapter, I really emphasized that you should draw your hexagon so it really looks like a regular hexagon. But when you're drawn three-dimensionally, you kind of want to skew that again. You want to kind of tilt it and slant it, maybe make it a little skinnier. So here's typically what my regular hexagonal prism looks like. I kind of make it long and skinny, and then I do another one up above here that matches it. And then start merging corners. If it's in the back, we dash it. If we can see it, we solid line it. And there's my hexagonal prism. Okay, now we're going to use, before we get started, we're going to look for surface area today, and I want to look at a net of that surface area. Remember when we made the net of our polyhedra, it's just all laid out flat. And if I'm going to look for the surface area of this prism, so this is my prism right here, here's the net that would make that prism. The base is a 3x4 rectangle. You can see a 3x4 rectangle here. And then it's 5 centimeters tall. And if I want to find the surface area, ultimately I'm just finding the area of all of these faces. And then I'll just add it all up. Now if you look at it, let's look at what we would have. Let's start with this. I know that this is broken off into 4 rectangles, but can't we just take those 4 rectangles and merge them into one big rectangle? And then this, the height of it would be 5, and the base would be all of these added up. So 4 plus 3 plus 4 plus 3. And that would be 14. So I could do this rectangle here, a 5 by 14 rectangle. And then I could find these 2 rectangles. If you look at where those are coming from, those are your 2 bases. And so I would find the area of that base, that's base times height, so that's 12, and that's 12, and I would add those into my big rectangle. Now, what I'm ultimately looking for here is a formula. So let's start with this big rectangle. The 5 is really just the height of your prism. And this long leg here is really just all these sides added up. If you look at it, it's this plus this plus this plus this. And if you think about it, well, that's just the perimeter of your base. To get this rectangle, I need to take the perimeter of my base times the height. And that right there is the surface area formula for, well, it's the start of a surface area formula for a prism. So it's surface area equals the perimeter of the base. Anytime you're dealing with the base, you use a capital letter. And then it's times the height of your prism. Now what I haven't taken into account yet, though, are the two bases. This base and this base need to be added in. Now, because that base is not always a rectangle, sometimes it's a hexagon, sometimes it's a triangle, I'm going to keep this formula very generic, and I'm just going to say, take the perimeter times the height. That's going to get us all these lateral faces around here, and add in 2, and then I'm going to put capital B, and capital B means area of the base. So if it's a hexagon, I'll find the area of the hexagon and then take it times 2 and add that in. If it's a triangle, then find the area of the triangle, take it times 2 and add it in. But this right here is kind of our go-to formula for surface area of a prism. All right, so here we go. Let's just do a few of these. What's the surface area of the triangular prism? It says use a net. Well, I'm not going to use a net because I have a formula I just figured out. And my hint on this is to remember there's always 2 matching sides that are the bases, because this right here is what we would call a triangular prism, but it's like sitting on one of its lateral faces. The base is really the matching triangles. So you have to think of, when I do area of the base, I'm talking about these 2 triangles. So if you would prop this thing up and make it sit on its base, how tall do you think it would be? It would be the 12 centimeters tall. Okay, so on your notes here, you can see I've goofed up. It says surface area equals pH plus, and there should be a 2 right here. So fix that in your notes. pH plus 2b. So let's fill in what we can. The capital P is the perimeter of the base. The base is the triangle, and the perimeter would be those 3 sides added up. So 5 and 5, that's 10, plus 6. The perimeter is 16. Now the height, if it were sitting on its bases, the height would be 12. Plus 2, and now I have to do the area of the base. And the area of the base, I'm going to come over here and do area of the base. It's a triangle. I have to go back to last chapter. Area of a triangle is 1/2 base times height. And now I'm just looking at the triangle itself. When I say, see how that's a lowercase b? That just means the b that's the base of the triangle. And then I'm going to need the height of the triangle. And what I know is that these 2 sides are 5, and the whole bottom is 6, which means when I drop that height, this becomes 3. Okay, so 1/2. The base, well, I talked about it, that's 6. The height, I'm going to have to work on. This is not a special right triangle, but I do know that this would be 3, and this is 5, and I could do a little Pythagorean theorem to find that height. So that's what I'm going to do. I'm going to do a squared plus 3 squared equals 5 squared. So a squared plus 9 equals 25. Subtract the 9, I get 16, so A is going to be 4. Okay, A is, and that's the height, right? That's going to be that measurement there, so I'm going to put a 4 here for the height. So 1/2 of 6 is 3, times 4 is 12. And that 12 gets put in right there for capital B. All right, now you're ready to go to your calculator and do 16 times 12, and that's 192. Plus 2 times 12, that's 24. Add those together, and you get 216 centimeters. It's still surface area, so we square the units on that. Okay, definitely using stuff from the last chapter here. Now, one of the things I should clarify before we get too deep into this, if they're asking you for the lateral area, that's going to be just the sides of it, and you don't have to add in the bases. So if they want the lateral area, you would just do the perimeter times the height, and then be done. If they want the surface area, then they're going to want the whole shebang. They're going to want the perimeter times the height, but you have to add in the two bases. Pay attention to if they're asking for just lateral or if they want the full surface area. All right, so this one says, using formulas, find the surface area of this prism. Now, we have ourselves here another triangular prism, but it's a little bit different. It's standing on its base this time, because remember the bases are matching shapes, these triangles. That's why we call it a triangular prism. All right, I know two sides of that triangle, plus I know that it's a right angle. Okay, so I'm going to work on that to find area of the base. Let's go ahead and start our formula here. Well, I know that I'm going to have to find area of the base. Can I start with that? Area of the base, it's a triangle, 1/2 base times height. And if you redraw that so you can see it better, you have a 3 and a 4. And if you want 1/2 base times height, you have what you need. The 3 is the base. The 4 is the height, because this is a right angle. So the base times the height. So half, oops, sorry, that's 3 times 4. All right, so that's half of 12. So the area of the base is 6. Okay, now I think I can go back to my surface area formula then. So I'll circle that. I know that's one of the things I'm looking for. Surface area is perimeter times the height plus 2 times the area of the base. The perimeter of the base. Uh-oh, maybe I got ahead of myself. Do you see how this is a 3 and this is a 5 or a 4, and then I need this also? That would be the perimeter. Okay, and I think we're going to do this in our head. This has happened a few times to us. It happened to us on the very last slide. This is what we call a Pythagorean triple. This is a 3, 4, 5 triangle. If you know two of the sides there, then the other one's going to fall into place. A 3, 4, 5 triangle. It's a Pythagorean triple, which would make my perimeter be 12. And then the height of the prism is this 6 right here, plus 2 times the area of the base, which I found earlier to be 6. That's a 72 plus 12, gets me 84 centimeters squared for my surface area. All right, let's try a hexagonal prism. This is a little trickier. It starts off and says, what is the lateral area? Then it comes back and says, what's the area of the base? And then C is what's the surface area. We don't really need to do this in parts. They're just trying to help you out with, here's your system. Here's how you do this. Find your lateral area. Find the area of your base. Add these together to get the surface area. This is another one of those prisms that's laying over on its side. The base is actually the hexagon, so we call it a hexagonal prism. And if you were to tip it up onto its base, it would be 12 units high, so that's your height. 6 here is one of the sides. All right, so let's see what we've got here. I'm going to have to find the area of the base to do the surface area, which means I'm going to need to know the area of this hexagon. All right, that's a flashback to last chapter. Let's go ahead and work on capital B because I know I'm going to need it. It's going to be 1/2 the apothem times the perimeter. Now, they were really nice about drawing this, and it looks very like a nice regular hexagon. So let me find a color that's going to stand out for us. Maybe this is black here. All right, so in this hexagon, that's my apothem. Remember this from last chapter? Okay, the apothem is right here. A hexagon actually is one of the ones that comes out nice as a 30, 60, 90. This little leg here would be half of the 6. So I've got a 3 for this little leg. And the height here would be 3√3. That's the long leg. And then this would actually be 6, but I don't really need the radius. What I wanted was that apothem right there. All right, so that's going to be 3√3. The perimeter of the base is the distance all the way around, and they told us that one side is 6. Well, 6 times 6 sides is 36. Let's go ahead and type this in. Let's keep all the decimal places there until the end, I guess. Okay, I typed that all in and I get 93.53. I'm going to call it that. 93.53. That's capital B. That's the area of the base. All right. Now, let's go find surface area. Surface area is equal to perimeter times height plus 2 bases. The perimeter of the base we already talked about. We used it. It was right here. It was this 36. The height, if we tip this thing up, we're talking about the prism now. The height of the prism is 12. Plus 2 times the area of the base, which we found earlier to be 93.53. Okay, now you have to be kind of careful with this, with the plus sign in here. Be careful with your order of operations. You would always have to multiply the first two together. And then you could probably put that in left to right because it'll multiply here and it'll multiply here before it does the adding. I'm going to do 2 times 93.53, then I get a 187.06, add the 423 to it, and I'm left with 610.06. Now, the directions do say round to a whole number, so actually I'm going to be done at my 610 meters squared. All right, that last chapter is not going away. We're going to be doing area of those polygons a bunch. Now, a cylinder is really just a special type of prism. So if you look at this, it still has 2 bases. It just happens that in a cylinder, the bases are always a circle. Okay, and if you think of like a label on a soup can, if you were to cut that label off like this, it would lay out flat as a rectangle. So to find the surface area of a cylinder, you're going to find the area of this rectangle and add in the 2 bases, just like always. And the area of this rectangle is the height times this length right here. But remember that that length just wrapped around the base, and so it would fit perfectly around this circle. And that distance around the circle is the circumference, 2 pi r. So I think what we have is a special formula here that we can use then for circles. We're still going to say the surface area is equal to the perimeter times the height plus 2 bases. But what's special here is your perimeter is really your circumference. So I'm going to put 2 times pi times the radius. And then I'm going to take that times my height. Plus 2, and then a capital B means area of the base. The base happens to be a circle, so that's going to be the area formula for a circle, pi r squared. Now you do not need to remember that. What you do need to remember is the area of the base formula and the circumference formula, and you'll fill that in as you go. I'm going to fill in numbers. I think I've got it here. Surface area equals 2 times pi, and then let's read up here. A cylinder has a height of 9 centimeters, a radius of 10. What is the surface area of the cylinder in terms of pi? So this time we're not going to round. 2 pi, the radius is 10, the height is 9. Plus 2 pi, the radius was 10, so I'm going to take 10 squared. All right, now I'm going to come up here. 2 times pi times 10 times 9. I'm just going to leave pi in my answer and do the 2 times 10, that's 20, times 9, that would be 180 pi. Plus, now I'm going to do the area of my base part, 2 pi 10 squared. 10 squared is 100, times the 2, that's 200 pi. And then this works just like it does with x's. You can just add these together. That's going to end up giving you 380 pi. And that's your answer right there. And that'd be centimeters squared. So if they ask you to leave it in terms of pi, don't ever type 3.14 in, or don't use your pi button. All right, I'm going to go ahead and move on to the next lesson, because we're just kind of powering through some formulas and using what we learned in the last chapter. Now we're going to do surface area of pyramids and cones. It's a little bit different. The sides of a pyramid are not rectangles anymore. Now the sides are going to be triangles. This is a square pyramid because the base is a square. The height of your pyramid is always that perpendicular height, usually coming straight out of the middle, straight down. It's got to be perpendicular to the base. So if they talk about the height of a pyramid, that's what they mean. But there's also this thing we call the slant height. And the slant height would be the height down the face over here. Now that's a different measurement. If you would look right here, it actually creates this weird right triangle that's like inside of the pyramid. And this would be the height. This would be halfway across the base. So if I knew this side length, it would be halfway across that. And then this is that distance down the side. That's your slant height. And you have this right triangle. So anticipate maybe some right triangle stuff that we'll do. Interestingly, there is also a right triangle over here on this yellow triangle. If you look at it like it's just that face, right here is coming down the side. That's your slant height. This is halfway across the base. And then this is like that edge of the whole, this is the edge of the pyramid. So that creates a different right triangle that we might use. Got some options here. Let's practice drawing to begin with. Same deal applies, like when it says a square pyramid, you're not really drawing a square. It's more of a parallelogram or a rhombus. And then instead of drawing straight vertical lines, you're going to pick a spot to be the vertex of this pyramid, and you draw everything to that spot. And there's your square pyramid. A triangular pyramid just needs to have a triangle base. And again, don't get caught up on that happen to be a perfect triangle. It doesn't, because we're going to look at it from a different angle. And there would be an example of a triangular pyramid. Let's use the net of a pyramid to see if we can come up with a formula. In a pyramid, you're going to have faces that are all triangles. So this right here shows that there's 4 triangles. And I'm going to find the area of that triangle and then take it times however many sides my base has. This particular example has a square base, so I'm going to have 4 triangles. All right, to do surface area, I'm going to find the area of these triangles, and then I'm going to add in 1 base, because a pyramid only has 1 base. If you look at what this is, remember we laid this out flat, so this slant height right here is really this height right here. So when I find the area of this triangle, I'm going to have 1/2 base times height. So 1/2 base is the side length. Height is your slant height. So this here is how you would find the area of that triangle. Now, you have to take that times how many there are. So however many sides there are, we usually call that n. But if you think about it, if I were to take that times n also, let's look at what is n times s always going to get you. The number of sides times the side length. That's perimeter again. So the ns piece is your perimeter. So I'm going to write a surface area formula. It's 1/2 the perimeter, and then times the slant height, so I'll use a cursive L for slant height, and then I have to add in whatever my base is, but there's only 1, so I put 1 capital B there. There's our formula for surface area of pyramids and cones. Here's an example of a hexagonal pyramid. The base is a hexagon. I know that I'm going to have to find the area of the base for my formula, so that's really where most of the work happens. So let's go ahead and let's work on the area of the base. Now I'm going to redraw this because when I find the area of a hexagon, I need my hexagon to really look like it's a regular hexagon. Because when I drop this apothem, I need to see that that's the long leg. All right. In this picture, kind of hard to see it, but it's coming from the center perpendicular to the side. That's the apothem right there. That's 6. Oh, no, sorry, my bad. That's 3 root 3. What is 6 is that side length. That's 6, which means this is, well, okay, I guess I'm just going to write that 6. To find the area of this hexagon, I'm going to do 1/2 AP, which really they gave me exactly what I wanted. 1/2, the apothem is 3 root 3. The perimeter is my 6 times 6 sides, so 36. Let's multiply that together. It doesn't really say what they want me to round to, so I'll just go ahead and get a decimal on this one. So I'm going to type 0.5 times 3 times the square root of 3, close that parenthesis, times 36. I have 93.53. Now that's the area of the base, right? That's what we were working on, the area of the base. So let's come down here and see if we can start filling in some stuff. 1/2, the perimeter of the base, we already found that earlier, that's 36, 6 times 6. The slant height, they give you in the picture, it's running right down the side, that's a 9. Plus the area of the base, we just found that, 93.53. Now let's type that in our calculator. And I end up with a surface area of 255 point, I don't know, 5. I guess we'll go 1 decimal place. It's area, so it's inches squared. On this example, they weren't nice enough to give me a picture, so let's see if we can draw it and figure out the surface area. A square pyramid, all right, square pyramid. Remember, you don't really draw it so it looks like a square. It's more of parallelogram. Okay. Has base edges of 5. Okay, so every side is 5. Slant height is 3 meters. The slant height is coming down the face over here. It's down this face. That slant height is 3 centimeters. What's the surface area of the pyramid? Okay. Well, I'm going to have to know the area of the base. The base is a square with all sides 5. Okay, that's not too bad. I think I can do that. All right, so here I'm just going to jump into surface area then. Surface area equals 1/2 PL plus 1 base. The perimeter of the base. Each side is 5. There's 4 sides. Perimeter would be 20. Slant height, they gave us 3. Plus the area of the base, this is just a square. I would just do base times height. 5 times 5 is 25. All right, I think we can do this one in our head. No calculator needed. Half of 20 is 10, times 3 is 30, and 30 plus 25 is 55 meters squared. All right, let's do another one of these hexagonal ones. They're a little trickier. It says find the slant height first, then find the surface area. What is the lateral area of the hexagonal pyramid at the right? Okay, it says lateral. Let's scribble that out. I'm going to go ahead and find surface area because it asks for that. But in order to do that, we have to find the slant height. Let's look at all this information they gave us. 36 feet. Okay, that seems big, but here we go. That's the side length right here. So we know a side. And if you look over here, you're coming from the center and you're coming in here and you're hitting the side. That looks like it's the apothem in that hexagon. Comes in here perpendicular to that side. And then the 42, That's the height of the pyramid, but it's not the slant height, and the formula says use the slant height. Hopefully you can see this. Sometimes you just got to have, that right brain, left brain thing where you can visualize things. But what's going on here is that you have a right triangle. This height coming out, and then right here going straight across that apothem, and then the slant height coming down the side over here. Okay, that's a right triangle. And I know two of those sides. In that right triangle, I know this is 18 root 3, and I know this is 42. I'm going to do Pythagorean theorem, and that's going to find this slant height for me here. So 42 squared plus 18 root 3 squared equals c squared. Now, I'm actually going to probably do the 18 root 3 first. So in my calculator, I'm going to do 18 times the square root of 3 and press enter. And then you should have just a squared button, just like an x squared. So if you hit your x squared button, it'll say, hey, take the answer and square it. If you don't have a squared button, then you're going to have to take that number and take it times itself. I end up at 972 for that. So just this part is 972. 42 squared is 1764. Let's add those together and square root it. All right, this did not come out quite as nice. I have a 52.3, and that is the slant height. So that would go right there, but ultimately, that's your slant height right there. Okay, the other thing that we're going to have to know to find the surface area is the area of the base. So let's work on area of the base. Okay, that's equal to 1/2 AP. So 1/2, the apothem they gave us, that was the 18 root 3. The perimeter is just all the sides, which each side is 36, times 6. And you get 216 for your perimeter. Let's multiply that stuff together. I have the area of the base to be a grand total of 3,367.1. Okay, let's fill it all in. The surface area is equal to 1/2. The perimeter of the base, we found that earlier. The perimeter of the base was right here. We said it was 216. That's the 36 times 6. The L is your slant height. That's what we did the Pythagorean theorem to find. Plus the area of the base, that's what we just found over here, the 3,367.1. Notice that that's being added, so that's a little bit different. So I'm going to type this in my calculator left to right. I'm going to go 0.5 times 216 times 52.3 plus 3,367.1. And my total surface area then for this figure is 9,015.5 feet squared. All right, well, let's keep at it. This one is a square pyramid, and it says find the slant height first and then go find your surface area. So I'm going to let you try this one on your own. Go find the slant height like we did last time, and then you can do your surface area formula. This one should be easier because the base is a square, and that's easier to find the area of than a hexagon. Take a minute to pause the video, and I want you to work through this one on your own. All right, I hope you got what I got. If you did not, take a minute to pause the video and look at my work to see where that came from. Now, we're going to kind of move on past the plugging and chugging through that formula, and we're going to kind of work backwards through a formula. They've given me a couple measurements on a square pyramid, and I'm looking for the missing ones. Okay, so on a square pyramid, the surface area formula would be, let's see, 1/2 PL plus 1 base. Okay, in this, I'm going to draw a picture here so you can see what's going on. Given two measurements of a square pyramid, find the missing ones. What would be missing in this formula? The surface area I already know is 39. They gave that to me. 1/2. They did not give me the perimeter here. But if each side is 3, you could figure out your perimeter. You'd have a 12. So they ultimately gave me the perimeter. Okay, slant height. I don't know that I have slant height, so I'm going to leave an L there. Plus area of the base. Again, they didn't straight up tell it to me, but if I know the two sides are 3, 3 times 3 is 9. What's missing then is the L. Let's solve for L. This is 39. Half of 12 is 6L plus 9. Subtract the 9 to the other side. So 30 is equal to 6L. Divide by 6. L is equal to 5. Now your units on that, that's not an area that you found. You just find a length, so it's just 5 inches for that length. Okay, let's try one more time. This time they gave me the height, and they gave me the slant height. I feel like they're going to probably be looking for the surface area then, because that's the thing that I don't know. I'm going to use my same picture. Let me get rid of these 3's. I don't know. Okay, I feel like I don't know very much here. What I know is the actual height is 8. And then draw that apothem over. And then the slant height down the side, because I know the slant height is 10. Could we figure this out then? Because that's going to drop perpendicular. We could do the Pythagorean theorem and find that missing piece. So let's do a quick 8 squared plus x squared equals 10 squared. That's a 100 minus a 64. That actually comes out nice. That's 36, which happens to be a perfect square. So what we found is that this piece here is 6, which means the full length across would have to be 12. If you look at your formula, we don't know surface area, 1/2. The perimeter, now that I know that this is 12, I could find perimeter. Slant height I know was 10. Area of the base I can find since I have the side length. So in this one, we're looking for surface area. That's what's missing. Surface area equals 1/2. The perimeter. Each side is 12, so I've got 4 sides. 12 times 4 is 48. The L, the slant height, that's 10. Plus the area of the base. That's base times height, or length times width. 12 times 12, 144. So then I'm left with half of 48 is 24 times 10 is 240. Let's add those up, and you get 384 for your surface area, meters squared. All right, thanks for sticking with me. I know this one's a long lesson here. A cone is the last thing, and it works just like the pyramid. It's just that we have special formulas for circle stuff. You still have a slant height. It's just down the side of the cone. You have an altitude or a height. That's a perpendicular measurement. You've got a circular base. And, of course, you have a vertex up here, a radius, those kinds of things. This is find the surface area in terms of pi. All right, so it looks like we're not going to necessarily use our calculator for evaluating that pi. Surface area, 1/2 PL plus B. 1/2, the perimeter. The perimeter on a circle is ultimately the circumference. So that's going to be times 2 pi r, and r is 15. So your perimeter is just circumference, times your slant height. Well, they gave us the slant height over there, the 25 would be your slant height, plus the area of the base. Okay, area of a circle is pi r squared, so I'm going to write pi times 15 squared. Now I don't want to really just jump in and type this in my calculator because I don't want to get that pi in there, but I could at least just do the number stuff. I could do the 0.5 times the 2 times the 15 times the 25. But I have to stop there because of the plus sign. So I've got 375 pi. Plus, over here, 15 squared is just 225. So that's 225 pi. Add the 225 to the 375, and you end up at 600. My surface area on this is 600 pi centimeters squared. Okay, that's all I have for you. Hope this helps.